Our next method of factoring is the difference of squares method. You will use this one anytime you have something that looks like something squared minus something squared. And if the formula that we have here is a squared minus b squared equals the quantity a minus b times a plus b. Now this should look familiar because we did talk about conjugates earlier in the course, where these are called conjugates, and when we multiply them together, the middle two terms end up canceling out. So like if I were to multiply these with distributing, I'd get a squared minus ab plus ab minus b squared, and then these two terms in the middle cancel out, and I get a squared minus b squared. So again, remember that factoring is the opposite of multiplying, and actually that's a good way for you to check your answers. As we move through some of these problems, if you want to see if your answer is correct, you could distribute it and see if you got what you originally started with. So here's another example, x squared minus 25. I'm going to start by comparing this to a squared minus b squared, and I'm going to try to set this up so I can figure out what to plug into my formula. Now it's not too difficult to see that instead of an a squared I have an x squared, which means that my a value must be an x. So everywhere I see an a in this formula, I'm going to replace it with an x. It's a little bit more difficult to see what the b value is. Right here I've got b squared equals 25. So then that means if I'm trying to think of something times itself that equals 25, I'd come up with either positive 5 or negative 5. And that's again kind of why these symbols work out the way they are, why one's a plus and one's a minus. So in this case my b value would be 5, and this would factor into x minus 5, x plus 5 would be our solution. Just one side note, don't forget that multiplication is commutative. So if you had x minus 5 times x plus 5, that's the same thing as x plus 5 times x minus 5. And then in terms of checking your answer, if you had some extra time on a quiz or something like that, what you would do is you would distribute your answer. So here we've got x squared minus 5x plus 5x minus 25. We've got like terms that add up to 0, and we've got x squared minus 25, which is what we started with, so I know that my solution of x plus 5, x minus 5 is correct. Let's try one more. This time I've got 4x squared minus 81. So I'd be looking for, if I'm trying to compare this to a squared minus b squared, I'd be trying to figure out, okay, if my a squared is 4x squared, I'm trying to figure out what times itself equals 4x squared. 2 times 2 equals 4, x times x equals x squared. And then it's a little bit easier to be able to see that my a value must be 2x. Same thing with my b squared. My b squared is 81. So I'm trying to figure out what times itself equals 81, and that's 9 times 9. So that's where our values are coming from, where our a must be equal to 2x, and my b must be equal to 9, and that's what's getting plugged into our equation here. So we get 2x minus 9 times 2x plus 9.